Environment variables are key value pairs that store the configuration details for a program. These can be database URLs, API keys, authentication tokens, and more. Instead of hard-coding this information in your program, it should be stored outside of your codebase to keep your program secure and flexible. Storing your API keys and authentication token outside your codebase adds a layer of security to your program. If your source code gets leaked to an unauthorized party, they won't have access to your authentication tokens and other sensitive information. In this video, I'll walk you through how to effectively organize and structure environment variables in a Rust program for easy and efficient access throughout your codebase. I will start by showing you how to set environment variables through the command line and access them in a Rust program. Entering your environment variables in the command line each time you run your program is very inefficient, so I will introduce you to the .env crate. With the .env crate, you can list your environment variables in a file and read the variables from that file into your program. Next, we will explore error handling when working with environment variables. Here I will share some useful tips and best practices for managing errors in Rust, including how to create custom error types. After that, we'll take a look at the lazy static crate. This will be used to create a static variable that will store the configuration struct created from the environment variables. I will name the variable config, and this will be global and made accessible anywhere in your program. It will also be thread safe, meaning that you can use it safely across multiple threads. Here is a preview of the final application. I have a .env file where I listed the environment variables for the program. I also have additional env files where I list the variables for local, development, and production environments. I then included a variable in the .env file to specify the current environment, allowing me to load the additional variables from one of these files. If a variable is included in both the .env file and one of the other files, the variable in the other file takes priority. I added all the environment files to a gitignore file to prevent sensitive information from being pushed to an external repository. For reference, there is also a .env.example file included to show the required variables without exposing actual values. In the main function of the program, I used the .env crate to load environment variables from the .env file directly into the program. Based on the app.env variable set in the .env file, I then loaded the variables specific to the selected environment file. I imported the config variable which I set up using lazy static. The config variable is a static pointer to this config struct. To access this config struct from the pointer, I first dereferenced it with an asterisk to get the struct, then used an ampersand to reference it. I then printed the configuration to the terminal. When I run the program, you will see the configuration printed in the terminal showing variables from the .env file. But take a closer look at the database URL. You will notice it's different from the one in .env. That's because app.env is set to local, so the program loads database URL from the .env.local instead. In this video, I'll walk you through the entire setup, starting from defining your program's environment variable in the command line and accessing it individually, to managing variables in a .env file and loading them seamlessly into your program using the .env crate. Let's start by setting up a new Rust project. Assuming you wish to set the port and database URL as the environment variables in your program from the command line, To do that in a Linux or macOS system, you can add the variables by stating their name followed by an equal sign and then their value before running your program. You can add multiple variables by separating them with a space. For Windows users, if you are working in the command prompt, here is the command you will need. If you prefer PowerShell, use this command instead. To access the environment variables you specified in your program, import the env module from the standard library. Now call the var function from the env module and pass in the name of the variable you wish to access its value. This returns a result enum with the OK variant containing the string from the variable and the error variant as the var error enum. The var error enum comes in two variants. One is the not present variant. It takes on this variant when the variable name passed is not present in the environment. The second is the not Unicode variant that contains an OS string. This occurs when the value passed in the command line after the equal sign is not a valid Unicode string, but a string that is only recognizable by the operating system. If you want to accept strings that may not be a valid UTF-8 string, you can do that without encountering an error by using the var OS function instead. This returns an option enum containing the OS string instead of a result enum. If the environment variable is not present, it returns the none variant. I will recommend you stick with the var function as OS strings are hard to come by and difficult to work with when compared to the regular string type. There is also a vars method that returns an iterator. Each element of the iterator is a tuple containing two strings. You can then iterate through it to get both the key and value of all the environment variables in your program. For each iteration, I will print their key and value to the terminal. When I run the program with port and database URL variables, a lot of key value pairs are printed to the terminal. This is because all these key value pairs were already added to the program by the operating system. You can find the database URL and the port variables in this list. Apart from using the command line, you have the option to directly set and remove environment variables in Rust within your program. You can do this through the setVar function. The setVar function is unsafe, so I will have to wrap it in an unsafe block. The first parameter is the key of the variable, while the second is the value. The setVar function is safe to use in single-threaded programs but unsafe in multi-threaded programs. To remove an environment variable, use the removeVar function. This is unsafe as well. I won't recommend using this method to set or remove environment variables in any situation. When dealing with numerous variables, setting environment variables through the command line can be inefficient. You would have to enter each variable whenever you run your program, which can be bulky and unmanageable. A much better option is to set a .env file at the root of your program and impute each variable on a new line. Each line should begin by declaring the variable name and then using an equal sign to assign the variable's value. To load the variables from the .env file into your program, we will utilize an external crate called .env. To add this crate to your program, in your terminal, in your projects directory, run the command cargo add.env. Once the process is complete, you will see the .env crate listed as a dependency in the cargo.toml file. You can now load the environment variables from the .env file into your program by calling the .env function from the .env crate. I will set the return type of the main function to a result enum, whose OK variant will contain the unit type, while the error variant will be an error thread object. This will allow me to easily propagate any errors I encounter. The .env function here returns a result enum, so we propagate the error by adding a question mark. Since this happens directly in the main function, this will end the program and print the error if it fails. Now that I have loaded the environment variables, I can then access each of them using the var function from the env module. To access the database URL and port variable, I will pass their variable name as a string to the var function. The var function returns a result enum, so I will propagate the error like I did with the .env function. The port and database URL variable now contains the content of their respective environment variables as a string. I can then print the content of these variables to the terminal. When I run the program, I can see the variables printed to the terminal. If there is no env file at the project's root, the .env function will return the error variant. When I remove the .env file and run the program terminates and prints the error value to the terminal. This is because I propagated the error in the main function. You can modify the error printed to the terminal using the map_err method. This is used to convert the error from one type to another. It takes in a closure with the original error as the parameter of the closure. Since I will not be using the error, I will use an underscore as the parameter. I can then return the new error type from the closure. I will use a string as the error type so I can easily add a descriptive message to be printed on the terminal. In Rust, any type that implements the display and debug trait can be used as an error type. To create a string, I will use the format macro but rename this as f to reduce the boilerplate, and then impute this message into the macro. When this program fails, the message will be printed to the terminal. If you try to access a variable that is not present in the env file, the var function will return the var error type. If the variable is optional, you can convert the result enum to an option enum using the OK method. The type of this variable is now an option enum containing a string. If the variable is required, you can convert it to a string explaining the error, just as we did for the .env function. But that is not what I will recommend in this case. When accessing environment variables, you can encounter two error cases. One is due to missing required environment variables. Another error you can encounter is when converting the value passed to an environment variable to your desired type. As an example, for the port variable, I would like to convert this to an unsigned integer. If you assign the port variable to a random string, you will get a conversion error which can also be called a parse error. Since we are dealing with much more detailed error cases, using a string won't be the best option. I suggest creating an enum to represent the different error types. I will name this enum config error and it will have two variants, the missing env variant and the parse error variant. The missing env variant accepts a string input, where we will provide the key of the required environment variable that is missing. The parse error variant will accept the key and value of the variable. For a data type to be used as an error, it must implement the debug and display trait. We can easily implement the debug trait for the config error using the drive macro. The display trait will be a bit of a challenge. Here is the boilerplate for implementing the display trait. The required method for implementing the display trait is the fmt method. This takes a reference to self and a mutable reference of the formatter struct from the fmt module. I named the parameter for this f. The fmt method should then return the result enum from the fmt module. Next, using a match operator, we will write into this formatter what should be displayed on the terminal. For the missing env variant, you can print the message "Missing required environment variable for blank." Here, we will pass in the key of the missing required environment variable. For the pass error variant, if the value given to the environment variable cannot be converted to the desired type, I will print the message "Failed to pass environment variable blank with value blank." I will then add the key and value in the next parameter. To make the config error an error type, I will now implement the error trait on the config error with a blank implementation. Since the database URL variable is required, after accessing the variable, before I propagate the error, I will convert the error type to a config error with the missing env variant. I will then impute the database URL as a key for the missing env variant. When I remove the database URL variable and run the program, you can see a detailed message on the terminal. Let's make the port environment variable optional and test the pass error variant. If the port variable exists, we will convert the string s to a U32 type, and if it fails, we convert the error to a pass error. I will set the key as port and value as the string that was passed to the port environment variable. If I change the value passed to the port variable to a random string and run the program, I then get this message printed to the terminal. The way we access each environment variable individually does not look clean. This is what the .env file for a simple backend service will look like. If you try to access each of them individually, you will end up with multiple variables, and this will get bulky and unmanageable. When dealing with a large number of environment variables, it is best to group them in a struct. You can then implement a method for the struct that will read the environment variables and create an instance of the struct with those variables. I am going to name the struct config, as this is an idiomatic way of naming the data that stores the configurations for the program. The fields of the config struct should contain each environment variable your program needs and their respective data type. The config struct here has a port field, which is an option enum containing an unsigned 32-bit integer, while the database URL and the JWT string have the string type. The AWS field is a nested struct containing the access key ID and the secret access key fields, which are both strings. I can then implement a fromEnv method on the config struct. I will set this to return a result containing the struct and has the config error as the error type. In this method, I will get the environment variables I need using the var function. Since the port is an option enum with the U32 type, if the port variable exists, it will be converted to an integer, and if it fails, I return the config error with the pass error variant. If the port variable does not exist, it uses none as its value. The other variables are required and are all strings. At the end of the function, I will return an instance of the struct wrapped in the OK variant of the result enum. In the main function, after the .env function, I then create a config variable and assign it to an instance of the config struct. Since the fromEnv function returns a result, I can propagate the error. I will implement the debug trait for the config and the AWS config struct. This will allow me to print the config variable to the terminal. When I run the program, you can see each environment variable printed to the terminal. Our main.rs file is a bit messy, so to clean this up, I will move everything related to the config struct to a different module. Typically, you would want to call the fromEnv method from the config struct only once, which is when the program is initiated. When you initialize the config struct, it is essential to share it globally throughout your program for maximum efficiency. I will show you how to optimize the config so you can access it easily and use it anywhere in your code. In your source directory, create a lib.rs file and a config.rs file. In the lib.rs file, add the config module and make it public. You can then move the config struct and all its dependents to the config module. Here you will need an external crate called lazyStatic. The lazyStatic macro in Rust allows you to create static variables that are initialized lazily, meaning they are only computed when you first access it. So any following access will use the already computed value. The lazyStatic macro also makes it easier to read and mutate variables globally. So add the lazyStatic crate using cargo add. When this is done, import the lazyStatic macro from the lazyStatic crate. To use this macro, after calling it, add a code block next to it. Within this code block, you will create and export a static variable which will be an instance of the config struct in this case. To do this, you should begin the variable declaration with the static keyword, followed by the ref keyword and then the variable name. I will use config in uppercase as the variable name since it's a constant variable. In Rust, static variables must have a static lifetime and be declared as a struct. Complex data types like structs, hash maps and vectors cannot be initialized as a constant. Therefore, the lazyStatic macro creates a static item that serves as a pointer to the actual data, which will be created during runtime. The ref keyword indicates to the compiler that this pointer is a reference. Let's specify the data type of the config variable as the config struct, then assign this to the return type of a code block. This code block will execute only once during runtime, and its return value will be stored somewhere on the heap memory. The static pointer created by the lazyStatic macro then points to that data on the heap. So the pointer is the actual static variable while the data is stored on the heap. Inside the code block, you can create an instance of the config struct using the fromEnv method. Since this returns a result, if the result is of the error variant, you can panic the program and display the error in the terminal. The panic macro terminates the program and prints the error passed in its argument in the terminal. If an instance of the config struct is created successfully, unwrap the result and return the value. Now the config variable is a pointer to the instance of the config struct. For the config variable to be accessed globally, you would have to make it public. The config variable relies on the config struct, so make it public as well. Additionally, the config struct depends on the AWS config struct, so I will do the same for it. You should make all the fields of the config and AWS config struct public in order to access them when needed. In the lib.rs file, I made the config module public as well. You can now use the config variable anywhere in your program and across multiple threads. In your main.rs file or any Rust file in your program, to import the config variable, after the use keyword, type the name of your program. In my case is Rust env. Then add 2 colons, the config module, and finally the config variable. To get the name of your program, head to your cargo.toml file and check the name field under the package table. Another tip you can use is this. In the lib.rs file, instead of making the whole config module public, you can re-export only the config variable and make it public. In the main.rs file, you can access the config variable directly from your program's crate. The config variable can only be used in borrowed form. If I try to assign the config to a variable, I get an error, and adding an ampersand in front of the variable fixes this. If I remove a required environment variable and run the program, you won't get any error yet. This is because the static config variable is a pointer to the config struct, which will only be computed the first time you access it. I haven't accessed the config struct or any of its fields yet. You can access the fields of the config struct directly from the config variable. Let's print the port field from the config. When I run this program, I then get an error from the missing environment variable. If I fix that and rerun the program, I can see the port printed to the terminal. Now let's print the config variable to the terminal. I have an error saying that the config variable does not implement the debug trait. But in the config module, you can see that the config struct implements the debug trait. This is because the config variable here is a pointer to the struct and not the struct itself. To access the struct directly, you should dereference it by placing an asterisk in front of the config. When I run the program, you can see the config struct and all its contents printed to the terminal. Sometimes your environment variable will be stored in a different file other than the .env file. For example, instead of just a single .env file, you can add additional files such as .env.local for variables just for your local environment, .env.development for variables specifically for development, and .env.production for variables intended for production. In this case, instead of just using the .env function, you can use the fromFileName function from .env. This takes a file name as a parameter, then loads the variable from the file into the program. Let's assume I'm in a local environment. The file for that will be in the .env.local file. When you run this program, it runs successfully since the .env.local file was found. If this extra env file isn't required, you can remove the error propagation. Now the .env.local file becomes optional, but the .env file is still required. I will call the OK method on this to convert it to an option enum, to stop this warning for not handling the result enum. If a variable is present in both the .env file and the .env.local file, the program will prioritize the value from the .env file as it's accessed before the .env.local file. To make the values from the .env.local file a priority, instead of the fromFileName function, use the fromFileName override function. Let's test this by copying the database URL variable from the .env file to the .env.local file. However, I will modify the database address from its IP to localhost. When I run the program, you can see that the database URL here uses the value from the .env.local file. It's best to make the file we pass to this from filename override function a variable that depends on the environment the program is running on. For this to be possible, we make this an environment variable which will be set outside the program. Therefore, in the .env file, I will make an entry for the environment of the program. I will use the app.env as the key for this variable. I will set it to local, but in a production environment, you should set it to production and so on. In the main.rs file, under the .env function, I will retrieve the app.env environment variable. To test this, I will run the program, and since the app.env was set to local, the database URL uses the local address. When building your application, always remember to include all env files to the git-ignore file to prevent leaking your environment variable. Another tip is to add a .env.example file that will contain a sample of the .env file. This will let other users of your code have an idea of which environment variables are to be included. You can then exclude the .env.example file in your git-ignore file. If I revisit the config struct, you can notice that for any new environment variable I add to the .env file, I will need to add a field for that in this struct. In the fromEnv method, I will also need to capture the environment variable and include the field and its value in the instance of the config. There is a config crate in Rust that makes this one step easier. If I make use of the config crate, I will only need to add a field for the new environment variable. It then handles the capturing of environment variables and any error related to missing variables or converting the string from the variable to the desired type. In the next video, I will show you how you can use this to not only create configurations from an env file, but also a JSON, TOML and YAML file. Thanks for watching and see you in the next video.